Okay, so today we're doing this optimization problem that says find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. So here we have any arbitrary circle and any arbitrary rectangle. So we can call this length and this height whatever we want. So let's call it x and let's call this height y. Okay, now what I can say from this rectangle so far is that the area is then going to be equal to x multiplied by y. Okay, the length multiplied by the height. Now let's suppose that the middle of the circle is somewhere around there. Okay, now what I can do is draw a diagonal for my rectangle, and what we can notice is that I've drawn a diameter, or we can say 2 radii, okay, because we know that the diameter is equal to 2 times the radius. Okay, now this question tells me that this circle has a radius of r, so we can say that this whole thing is just 2r. And from rectangles we know that the corners are going to be perpendicular, so we have a right angle right there. And also this length is going to be x. Why? Because these lengths are the same, and then that implies that these heights are also the same. But we're going to be focusing on this right angle triangle that we've constructed so far. Okay, now what do we know about right angle triangles? Well, we know from Pythagoras that the hypotenuse, all squared, is going to be equal to the side lengths squared. Okay, and we can state that this is from Pythagoras. Now simplifying this is going to be 4r squared equals x squared plus y squared. Now they tell me that they want us to maximize the area, but this area is in terms of x and y. So now we can choose one variable to solve for. I'm going to choose y so that we can sub in for y and then take the derivative with respect to x. So I'm going to say y squared is equal to, and then subtract x squared from both sides, so 4r squared minus x squared, and then taking the square root, we can say that y is going to be equal to the square root of 4r squared minus x squared. Now let's sub that in, so our area is now equal to x multiplied by the root of 4r squared minus x squared. Now notice that we can write this as 4r squared minus x squared to the power 1/2, because the power of a root. Now let's find a prime, because we want to set a prime equal to 0 to find the maximum. So a prime is going to be equal to, taking the derivative of this, notice that we have a product rule that we're going to have to do. So I'm going to copy down the first function. Now taking the derivative of this, which is the same thing as taking the derivative of this, is going to be 1/2. Copy whatever's in the brackets, so 4r squared minus x squared. Now minus 1 from the exponent, this is going to be minus 1/2. Now multiply by the derivative of whatever's inside the bracket. Now before I take the derivative of 4r squared, notice that this is not related rates, this is optimization. So r is not a variable here, r is a constant, because r is gonna stay the same. The radius is not increasing or decreasing, it's gonna be the same. So taking the derivative of 4r squared, that's just going to be 0. And now taking the derivative of minus x squared, it's going to be minus 2x. Now we do have a product rule, so we can say plus. Now the derivative of x is just going to be 1, and then we can just copy down the second function, so 4r squared minus x squared. Now this one we can just take out the 0 because that's the same thing as minus 2x. So let's tidy this up before we set it equal to 0. Now multiplying all these together, we get minus 2x, and that's going to be squared because we have two x's. And now taking this negative exponent to the denominator, so it's going to be the root of 4r squared minus x squared. So I took it to the bottom and then I used power over root to convert it back. And then let's not forget the plus 4r squared minus x squared. Now let's set this equal to 0. Okay, now we can cancel these 2's because they're in the numerator and denominator, and we can say that this is minus x squared all over 4r squared minus x squared plus 4r squared minus x squared. And actually I'm going to put the 0 on the right hand side. Now let's multiply through by the root of 4r squared minus x squared, and that's going to look something like this. Okay, so we're going to multiply these together. Now if I do that, these are going to cancel. Okay, so this is going to be minus x squared plus. Now if I multiply this with this, the roots are going to cancel. So I'm going to have plus 4r squared minus x squared equals 0. Now combining like terms, taking the 4r squared to the right hand side, let's divide both sides by minus 2, so we get 2r squared. Now let's take the square root, so that we get x is equal to plus or minus the square root of 2r squared. We can separate these. It's going to be plus or minus root 2 square root of r squared is just r. Now let's think about this. Can the length of the rectangle be negative? Because this is the length that we've just calculated. Okay, can the length be negative? No, it cannot. So this is just going to be, well, we can say x cannot be equal to minus 2r. So hence this implies that x is equal to 2r. Okay, or root 2r. So now we have x, but we still don't have y, which is the height. But we do have an expression for y. So let's sub in x, and let's not forget that it's all squared. So this is going to be root 2r all squared. This is going to be the root of 4r squared minus, now if I square root 2, it's going to be 2. If I square r, it's going to be r squared. Combining like terms, we get 2r squared. Now separating these, we get root 2 r, and hence x is equal to root 2 r, and y is also equal to root 2 r.